Have you ever wondered about the celestial bodies that reside in the shadow of the 8 major planets in our solar system? Well, you're in for a treat today, as we set our sights on the often overlooked but equally intriguing dwarf planets. These celestial underdogs are a part of our cosmic neighborhood and hold the potential to reveal secrets about our universe's origins and evolution. Imagine our vast solar system, home to a myriad of celestial bodies, all performing an eternal dance around the sun. This cosmic ballet features a diverse cast, including planets, moons, asteroids, and comets. But today, we're spotlighting an intriguing group that often gets overshadowed by their larger counterparts: the dwarf planets. These celestial bodies occupy a fascinating niche, one that's at the intersection of planetary dynamics and cosmic curiosity. Dwarf planets, as defined by the International Astronomical Union in 2006, share many characteristics with regular planets. They orbit the sun, possess sufficient mass for their self-gravity to mold them into a nearly spherical shape. But there's a catch. Unlike the planets we're familiar with, dwarf planets haven't cleared their orbital neighborhood. In simpler terms, they share their cosmic lane with other celestial bodies. Dwarf planets are scattered throughout the solar system, with many residing beyond Neptune's orbit, in a region known as the Kuiper belt. And yes, Pluto, the celestial body that most of us grew up learning was the 9th planet, is one of them. But it's not alone. There are others like Eris, Haumea, and Makemake. And then there's Ceres, the only dwarf planet nestled within the asteroid belt between Mars and Jupiter. So, what's the big deal about these lesser-known celestial bodies? Why should they matter to us? Well, understanding dwarf planets provides us with a broader perspective on the solar system's dynamics, the formation and migration of celestial bodies, and the processes that shaped our cosmic neighborhood. Let's dive deeper and unravel the mysteries of these lesser-known celestial bodies. Stay tuned as we journey into the realm of dwarf planets, exploring their origins, their unique characteristics, and the significant roles they play in our understanding of the cosmos. What makes a celestial body qualify as a dwarf planet? This question led to a significant shift in our understanding of the solar system when it was addressed by the International Astronomical Union, or IAU, back in 2006. The IAU, the body responsible for classifying celestial objects, realized that our solar system was more diverse than we had previously thought. There were objects out there that didn't fit neatly into the categories of planet, moon, or asteroid. These objects were something different, something in between. They were dwarf planets. So, what are the key characteristics that define a dwarf planet? Firstly, like all planets, dwarf planets orbit the sun. They aren't moons orbiting other planets, nor are they artificial satellites launched from Earth. No, these bodies are independent travelers on their own paths around our star. Secondly, dwarf planets have sufficient mass for their self-gravity to overcome rigid body forces. What does this mean? Essentially, they're big enough that their own gravity pulls them into a shape that is nearly round. They're not perfect spheres, but they're far from being irregularly shaped like most asteroids. But here's where dwarf planets differ from the so-called true planets. Unlike the 8 planets in our solar system, which have cleared their orbit of other debris, dwarf planets have not. They reside in zones of space where there are many other bodies of a similar size. This inability to clear their neighborhood is what differentiates a dwarf planet from a full-fledged planet. These definitions have helped astronomers categorize the celestial bodies in our solar system more accurately, and they have led to some fascinating discoveries about the diversity and complexity of our cosmic neighborhood. Now, armed with the knowledge of what constitutes a dwarf planet, we can explore some of the notable inhabitants of this category. Beyond Neptune's orbit lies a world of icy bodies, among which reside some of the most famous dwarf planets. Here, we find Pluto, once esteemed as the 9th planet of our solar system. Its demotion to dwarf planet status brought it into the company of other fascinating celestial bodies such as Eris, the most massive dwarf planet discovered to date. Then we have Haumea, a fast-rotating elongated dwarf planet known for its unique shape and ring system. Not far from Haumea, we encounter Makemake, an icy wonder named after the creation deity of the Rapa Nui people of Easter Island. Our journey through the realm of dwarf planets would not be complete without a stop at Ceres, nestled within the asteroid belt between Mars and Jupiter. As the only dwarf planet in the inner solar system, Ceres presents a contrast to its distant cousins. Each of these dwarf planets contributes uniquely to our understanding of the varied nature of our solar system. Pluto, once hailed as the 9th planet, faced a controversial demotion in 2006. The International Astronomical Union, or IAU, redefined what it means to be a planet, and unfortunately, Pluto didn't make the cut. It was reclassified as a dwarf planet, a decision that sparked heated debates among scientists and stargazers alike. The main contention rested on whether Pluto had cleared its orbit, one of the primary criteria in the IAU's new definition. The controversy wasn't just about Pluto, though. It prompted a broader discussion about our understanding of planetary dynamics and the very nature of celestial classification. Ultimately, this controversy fostered a more profound appreciation for the diversity of our celestial neighborhood. It reminded us that irrespective of labels, each celestial body has its own unique story to tell in the grand narrative of our universe. Though demoted, Pluto's importance in our understanding of the solar system remains undiminished. Among the dwarf planets, Ceres holds a unique position. Nestled within the asteroid belt, between the orbits of Mars and Jupiter, it stands as the only dwarf planet in this region, making it a subject of immense interest. Ceres was first spotted by the keen eyes of Giuseppe Piazzi in the year 1801, making it one of the earliest celestial bodies to be discovered beyond the realm of visible planets. But it wasn't until the year 2006 that it was officially recognized as a dwarf planet by the International Astronomical Union, joining the ranks of other notable bodies such as Pluto, Eris, Haumea, and Makemake. But what sets Ceres apart from its fellow dwarf planets is not just its location. In 2015, NASA's Dawn mission made a rendezvous with Ceres, marking the first time a spacecraft had ever visited a dwarf planet. This close encounter with Ceres provided a wealth of information about this intriguing body. The Dawn mission unveiled a landscape punctuated by craters, mountains, and intriguing bright spots that scientists believe may be deposits of sodium carbonate or other salts. These features hint at a past marked by geological activity, suggesting that Ceres is not just a static, rocky body, but a world with a complex history. Moreover, the mission uncovered signs of water ice on Ceres. This discovery is significant as it points to the possibility that Ceres, like Earth, might have harbored conditions conducive for life at some point in its past. The study of Ceres continues to yield insights into the early solar system, the nature of the asteroid belt, and the conditions that may exist on other dwarf planets. It's a testament to the diverse and dynamic nature of our cosmic neighborhood. Ceres, with its unique position and composition, continues to intrigue scientists and space enthusiasts alike. Dwarf planets, though small, offer significant contributions to our understanding of the solar system. These celestial bodies are like time capsules, preserving the conditions prevalent during the early stages of our solar system. By studying them, we can piece together the puzzle of how our cosmic neighborhood came to be. Dwarf planets give us insight into the migration patterns of celestial objects. For instance, the orbits of these bodies can tell a tale of gravitational interactions and dynamical chaos in the early solar system. They also help us understand the distribution of volatiles, substances like water, methane, and ammonia, which are essential for life as we know it. Moreover, the diverse compositions and surface features of dwarf planets allow us to explore the broad spectrum of evolutionary processes that shaped planetary bodies. Each dwarf planet, with its unique attributes, adds another layer to this rich tapestry of knowledge. Indeed, these tiny celestial bodies hold keys to some of the biggest mysteries of our universe. The Kuiper belt, a region of icy bodies extending beyond Neptune's orbit, is a treasure trove of dwarf planets. This vast, cold frontier is a living time capsule, preserving remnants from the solar system's infancy. Its inhabitants, dwarf planets like Pluto, Eris, Haumea, and Makemake, serve as celestial Rosetta Stones, their compositions and orbits holding keys to understanding our cosmic origins. The Kuiper belt's importance cannot be overstated. It's akin to an astronomical gold mine, filled with knowledge about primordial conditions and the early evolution of the solar system. Yet it remains largely unexplored and its potential unutilized, much like an unread book of our cosmic history. Looking to the future, advancements in technology and observational techniques promise to shed more light on the Kuiper belt's riches. Planned missions and telescopic surveys aim to uncover more dwarf planets, and with them, unravel the mysteries they hold. As we continue to explore, the mysteries of the dwarf planets and the Kuiper belt await to be unraveled.